So with this series, we aim to understand precalculus in order that we can prepare ourselves for calculus 1, 2, 3. We need to understand the fundamentals of precalculus first, and these includes properties of real numbers, addition and subtraction of real numbers. We need to understand the multiplication and their division. We also need to be able to understand the real line. Okay, what does it mean? It's got so many applications. We need to understand the sets and intervals, their notations. We also need to understand the absolute value and distance, such as distance between points and so on and so forth. We need to practice these aspects a lot in order that we can become really good with calculus. The second aspect that we are going to have to understand is what the real numbers are actually. So the most important thing to understand is that we can't measure and we can't compare quantities if we don't have real numbers. And so what are these real numbers? I think the only way to understand them fully is if we understand their groupings. And so the groupings of real numbers includes the natural numbers, integers, rational numbers, and irrational numbers. What are natural numbers? These are usually what we use for counting. Integers would be what? Integers would be these same natural numbers, and then we include a 0, and then we include their corresponding negative numbers. For example, 1 has got -1, 2 has got -2, and so on and so forth. Another concept that is so important and crucial is the rational numbers. And so these are numbers that we can express as ratios usually. So you have rational and then ratio, so it's easy to remember. This can be represented as R is equal to A over B. We have irrational numbers. Normally, we say that these cannot be expressed as ratios, so they're not really expressed as ratios most of the time. So these are square root of 3, for example, pi. You can have so many of these. The key to understand is that we don't represent these as ratios normally. And then we talked about real numbers, their types. Now, we also need to understand what can be done with these real numbers. So when you're adding, when you're subtracting, when you're dividing and all that, the first concept is that they're commutative. You can interchange them when you're adding or multiplying, and there will be no difference there. They're also associative. What does it mean? It means that you can group them. That will not change the answer if you're multiplying or dividing. Multiplying or adding. Then we can also say that they are distributive, meaning that you can expand, like we've expanded here. A goes with B, and then A goes with C, then you have AB plus AC. You can also expand larger groups, like we've shown there. So at the end of the day, this is something that we looked at already, but once you expand, it gives you that expansion. That's also reversible. You can reverse it to its origin. Another important concept when it comes to real numbers is what you can do with the negatives. Okay, how does it impact when you're multiplying? So, for example, a negative and a positive, once you multiply them, you get a negative. A negative and a negative gives you a positive. So these are just examples of where you can actually see the negative in play. So for example, here, minus times minus A minus B gives you positive and positive, and it's the same as A plus B. This other one, again, if you expand the brackets, you have minus a plus b. That is because there are certain things that change when you're multiplying a negative and a positive. So you need to know how these two interact in terms of division, addition, and multiplication, and so on and so forth. Another important aspect that we need to understand is, for example, multiplicative identities. You know, if you multiply a number by 1, for example, you get that number. So, for example, a times 1, you get a. So we have the 1 there as the multiplicative identity. Okay, that is when you are multiplying. What about division? Division, for example, a over b. What does it mean? So in this case, a will be our numerator, b will be our denominator, and the answer to this gives us now the quotient. Okay, so another crucial concept to understand. When we are also multiplying, what do we do? It's like it's in a straight line. So a goes with c, b goes with d. So you get ac over bd. And then division, the most crucial concept when it comes to division is inversion of the divisor. Okay, so we're going to invade, and then we have b over, we have d over c there. Then when we multiply, we get ad over bc. Another important one is when we are adding. When the denominator is the same, we just add the top parts to get our answer. When they're different, we get the lowest common multiple, and then that's the one that we put under, and then do all the divisions there. Okay, then we also need to understand the cross multiplicative factor. When you have these on different sides, you can actually multiply them but across, and then you have AD is equal to BC. So that's another crucial concept. And then one of the most important things in mathematics is being able to understand graphing. And all graphing comes from the number line, okay, the real number line, coordinate line. Doesn't matter what you call it, as long as you know this is what you're talking about. So there's an origin, and from the origin, if we go left, we go negative numbers. If from the origin we go right, we go to the positive numbers. Further right we go, the larger the numbers. Further left we go, the lesser the numbers. Okay, and so we have to understand what these coordinates are. Okay, because that's the fundamental when it comes to graphing, and there's no calculus without graphing. So we need to understand units left, units right. Units left is more positive, right, sorry. Units left is more negative. So we need to understand, if we put a point A on the right, B on the left, A will always be greater than B. Okay, that is number line. Thank you.